The tension is the force exerted by a rope that is pulled tight. Our objective is to understand how equilibrium works by calculating the tension of two ropes at 0 and 45 degrees from the center where the object is hanging.
Wood board that contain all of the angles needed, wrench, keychain ring, orange rope, 2 bolts, 2 nuts, weight of 1 kilogram, weight of 500 grams. First we had to construct the wood board in order to mark in it the angles needed. Then we had to mark the desired angles. Then we had to make a hole in the top of the line of the desired angles. We inserted the nuts and bolts in each of the angles needed. We put the weight in the middle of the rope using the keychain rings. After that, we attached the rope with the bolts by making a knot in each of the endings of the rope and pulling them very tight. We made sure that the weight stood in the center of the board. Finally, we made our calculations to get the two tensions depending on each weight and angle required.
The first thing we had to do in each of the problems was to draw the free body diagram, which represents all the forces involved and the angles of the rope in both sides. When we had established that and we are aware of all the known data, we must apply the tension formula in the x and y axis. This means summatory of x values equals 0 as well as the summatory of y values. We substituted the values of the angles first in the x-axis using t1 times cosine of the angle minus t2 times cosine of the angle equals 0, and from there we isolated t1. We substituted the isolated t1 in the formula of the y-axis. t1 times sine of the angle plus t2 times sine of the angle minus the weight equals 0, and we will get the value of t2, which we will substitute in our first x-axis formula to get the value of t1. This process is repeated in the second problem with changing the given values of the angles and weight.
This experiment clearly relates with the first Newton's law, because a characteristic of an object in equilibrium is that it must not have acceleration, and to accomplish that we follow the first Newton's law. An object in rest will remain in rest, or an object in motion will continue in motion with the same speed and direction if no external force acts on it.
As we were doing our calculations, we noticed that depending on which angle does the rope is, the greater or lower tension it will be exerted. So we make a little investigation according to Rope Book 2018. The ideal angle is from 45 degrees between the two rope vectors. Rope Book says, when bringing a rope, the ideal angle is approximately 45 degrees. At the ideal angle, there would be 24% of the load's weight being distributed to each anchor device. Although this is over half of the original weight of the load, we have still gained an advantage by sharing it between the two anchor points. This means that if we want to have the ideal angle in our project, we should have used 67.5 degrees in each angle rope, and that would have led to the ropes to have an internal angle of 45 degrees. O sea, the ideal angle, because 67.5 degrees plus 67.5 degrees from the angles will make plus another 45 degrees, the internal angle between the ropes, equal to 180 degrees from our system. When continuing with our investigation, we also noticed that there are angles that need a lot of tension in order to have equilibrium in the object. Rope Book 2008 states that whenever the internal angle between two ropes tends to 180 degrees, the greater tension of the rope will be.
The tension of a rope at 45 degrees with an object that weighs 9.81 newtons is greater than the tension of a rope at the same degrees but with an object that weighs 4.9 newtons. The tension of the rope will not be equal to the weight of the object. We can conclude that even although we didn't have the best angles, we noticed that the greater the weight, the greater the tension. We were able to identify the Newton's law applied, relating the problem given with the first Newton's law, and in this way it was easier for us to understand how it works.